For section 7.2, number 2, the question is find the volume of the solid whose base is the region bounded by these two curves, y equals x to the 7th and y equals 1, and the y-axis, and whose cross-sections perpendicular to the y-axis are equilateral triangles. Okay, so this is not one of those solids of revolution. This is a volume whose cross-sections are equilateral triangles. So let's try to draw this region real fast. So y equals x to the 7 and y equals 1. Let's see, y equals 1 would be right here. And y equals x to the 7 looks kind of like a steep parabola. And it would stop right there at y equals 1. So here's y equals x to the 7th. And the y-axis is right here. So this is our region right there. Now, what we're going to do is we're going to think of each of the cross-sections perpendicular to the y-axis. So here is a cross-section that's perpendicular to the y-axis. That should be an equilateral triangle. So you imagine a triangle coming up from right here, an equilateral triangle. Let's see if I can sketch this in kind of a three-dimensional way, where this is the y-axis, this is the x-axis, here this is the y-axis, and this is the x-axis. There's that same region, and if I tried to draw one of these cross sections, it would look something like this. There's that same cross section, but each piece would be one of these equilateral triangles. So there'd be a bunch of these equilateral triangles starting off really small and getting bigger like that. So the way that we figure out these these volumes is the volume is the integral of all the cross-sectional areas. Now here we're going to integrate with respect to x, because these cross-sections are going to move from x equals 0. We're going to integrate with respect to y. So here I'm not moving from x equals 0 to x equals something. They're moving from y equals 0 to y equals 1. So we can also think of the volume as the integral of a of y with respect to y. And here it's going from y equals 0 to y equals 1. This distance right here, this distance is x. If this is an xy point, the x distance is right here and the y distance is right here. So this distance is x. Now if I were integrating with respect to x, I'd just put an x in there. But I need to figure out what x is in terms of y. Well, in terms of y, x is equal to, if I solve this, I'd have the 7th root of y, or y to the 1/7. So I know that my formula is going to be the volume equals the integral from 0 to 1 of some function with respect to y. And I know that this distance right there is x, or y to the 1/7. But I need to figure out what the area of an equilateral triangle is. Alright, so if I draw an equilateral triangle, let's see, here's an equilateral triangle, and I know that this distance right here is the same as that distance. This distance is x. This distance is also x. One way you could have this formula memorized, or you could think of the area as 1/2 base times height. The base of this triangle is x, and the height of this triangle is this distance right there, whatever that height is. Well, you could think of this as a 30, 60, 90 triangle right here. This is x over 2. Or you could do the Pythagorean theorem. If you say, like, this is the height right here, the height would be height squared plus x over 2 squared equals x squared, right? This side squared plus this side squared equals this side squared. If you did this Pythagorean theorem, h squared would equal, let's see, this would be x squared over 4. So if I brought that over the side, I'd have 1x squared minus a 4th x squared would be 3/4 x squared. And h would be equal to, well, if I took the square root of this, it'd be the square root of 3 over 2 times x. And you might notice that it's this thing times the square root of 3, which is what we get when we have the square root of 3, when we have a 30, 60, 90 triangle. So the height should be square root of 3 over 2 times x. Now that's a non-trivial part to figure out this area, but the area of an equilateral triangle in terms of its base is square root of 3 over 4 x squared. X times x is x squared, 2 times 2 is 4, and the square root of 3 is right there. Okay, so this is like some side geometry. There's not a lot of calculus here, but if I want the area of a triangle in terms of its base of an equilateral triangle, that's it. So now remember, it's x, but I want it in terms of y, so I'm going to write the square root of 3/4. Sorry, my pencil is just breaking a lot. Square root of 3/4, but instead of an x squared, I'm going to write what x really is. X is y to the 1/7. And that's the thing I'm going to square right there. Okay, so I've done the hard part. I've set up my integral. Now I just need to integrate. So let's see what I've got. So the volume is the integral from 0 to 1 of square root of 3/4 y to the 2/7 dy. So I can take that square root of 3 over 4 out. The integral of y to the 2/7, well, it must be y to the 9/7. That's what I get if I add 1 to 2/7. I'm going to divide by 9/7 or multiply by 7/9 and evaluate this from 0 to 1. 0 and 1 are nice things to plug in. So let's see, if I multiply this together, I get 7 square root of 3 over 36. And if I plug in a 1, 1 to the 9/7 is just 1. If I plug in a 0, I get 0 to the 9/7, which is 0. So my final answer here for this one ends up being 7 square root of 3 over 36. And that's it.